Hello everyone, this is Indradeep Kumar, Assistant Professor, IARE, Hyderabad. In this video, we will see column with one infix, that's the fourth condition. Column with one infixed and other is already we had seen that one infix and other free. So now one fixed, one nil. And then we will see Euler's formula and equivalent length of a column. Next, we will see after finishing that Euler's formula and equivalent length of a column. This already I told you, that's why I wrote L by 2 in previous videos, right? So equivalent, in terms of equivalent length we will see. Okay. Next, then we will see what is slenderness ratio, or about slenderness ratio, and then limitations of Euler formula. So these things we will see in this video. Okay, so let's start first. That column with one infixed and the other hinged. So here is the diagram. So just see again. Consider a column AB of length L fixed at A and hinged at B. So fixed at A, hinged at B, and carrying a critical load P at B. Carrying a critical load, that is P at B. As a result of loading, then the column deflects as shown in figure. So here it's fixed. This here it will be like this, right? But this is when this one is hinged, so that will be like this one. Okay. So now let P is critical load on the column and Y is the deflection of the beam at X. So these things will be same for all, just you have to mention the condition, that's all. That is, one is A is hinged or B is hinged, A is fixed, B is fixed, whatever, that only will change, remaining all this will be same. So now let's see if same again here, from here this time at a distance X, deflection is Y, that condition. Now here this horizontal deflection will also act, so that we have to take care. So let's see. A little consideration will show that since the beam AB is fixed at A and is carrying a load, therefore there will be some fixed in moment at A. So at this point, fixed moment will be there, that already we used. Okay. Next, in order to balance the fixing moment at A, there will be horizontal reaction at B. So just to balance, earlier in previous videos we have seen both infix. So here one was clockwise, the other one was anti-clockwise, and that's why it's got balance. But in this case, only at this point moment is there. Means definitely another horizontal force is required, so that force into distance will be what? Get managed, that means get nullified this moment. Okay, so that's why there will be horizontal reaction at B. So that acts as the horizontal reaction. Let MA is the subscript. MA, that is here, is what fixed in moment at A, and H is the horizontal reaction at B. So whatever is figure that you have to write. Next, the moment due to critical load P, that because of the P, that is minus Y because it's a concave one, right? And moment because of this one force will be what? H into this total is X. So sorry, the total is L, and up to this is what? X. So this distance is what? L minus X. So H into L minus X will be the moment. So H minus X is because of this horizontal reaction, and minus Py because of this load. So overall moment will be what? H into L minus X minus Py. Next, what we have to do? Same again, take this Py to the other side. So Py will be this side, and divide what? By Ei. Means just because the coefficient of this should be 1. So divide Ei with each term. So what we will get after dividing? d2y by dx square plus P by Ei into Y equals to H minus Lx by Ei. Now here again, what is that? P is not there. Means what we have to do? Divide and multiply by P. So this P and Ei you have to remove. What will be there? H into L minus X by P. General solution. Remaining term for this will be same. Just here. So this will be, sorry, actually here this will be Y and this is A. Mistake, this is Y, this is A. Okay, so after finding this, what happened? Y equals to A cos X root P by Ei plus B sin X root P by Ei plus H into L minus X by P. Okay, now same again the boundary condition where A and B are constant of integration. So writing this is important. Okay, earlier also I told you. We know that when X equals to 0, Y equals to 0. So put X equals to 0 and Y equals to 0. So 0 equals to A cos 0 into root P by Ei plus b sine 0 into root p by ei plus h into L minus x by ei. Sorry, p. H minus L x into p. So now after this, sine 0 is 0. So this term will be 0. Cos 0 is 1. So 0 equals to a plus h into L minus x by p. So from here a equals to, that implies a equals to minus of h L minus x by p. Okay. So what is that? X equals to 0. So here put also 0. So what you will get? Minus h L by p. That is a. So here minus sign will be there. So minus h L by p. First condition we applied. After that, what we are doing? Second boundary condition, differentiate. So same, differentiate. After differentiating, what you will get? This term is common, right? So differentiation, this what we can write this term as h L by p minus hx by p, right? This term we can write like this one, just multiplied and separated. So h L by p. So now differentiation of h L by p is what? 0, because with respect to x we are differentiating. And differentiation of minus hx by p is what? Minus h by p. So minus h by p. So now we have the differentiation. Next what? Again apply the boundary condition at x equals to 0. What? dy by dx equals to 0. So put x equals to 0, dy by dx equals to 0. So 0 equals to what? This will be 0 equals to same. This term will be what? 0, because sine 0 is 0. So 0 plus b root p by ei cos 0 into this is 0 minus h by p. So cos 0 is 1. So that's why b root p by ei minus h by p. So take this side. So h by p is equals to what? B root p by ei. What we have to find? B. So b will be equals to what? Sorry, h by p. This will be there again here. H by p. So b is equals to h by p into this will be what? Reciprocal of that one. So ei by p. Okay, this root. So this will be the value of b. Now we have a and b. Substitute here. Okay, then what we will get? But we also know that third. At x equals to L, y equals to 0. Therefore, substituting the value of x, a and b in equation 1. So y is 0. What we got? So here this is minus, that we remove because value of a is minus h L by p cos L root p by ei, and value of b is this one, h by p. This is here. That's why here just it's a misprint. H by p root ei by p sine L root p by ei. So after substituting the value. So now this is minus, this is plus. So take this side. So what happened? H L by p, this to that side, cos L root p by ei equals to this term, h by p root ei by p sine into sine of L root p by ei. Now just see here, h by p we can cancel it. Okay. Now what is left? This one. Okay. So just see here what we can write. So I am taking this part, this side, and cos this side. So sine L root p by ei divided by cos L root p by ei equals to what? Here L was left, L, and here this term root ei by p. L divided by root ei by p. So this we can write as L root p by ei. So sine theta by cos theta is what? Tan theta. So can we write this as tan L root p by ei equals to L root p by ei. Okay. Now same again, a small consideration is required. So just see here you have to take care. Okay, somewhat that earlier that was generally directly, but here you have to remember one thing. What is that? a little consideration will show that the value of L root P by EI in radian has to be such that its tangent is equal to itself. Just see here, this word is very important. This be such that tangent is equal to itself, and that happened around 4.5 radians. At 4.5 radians, tangent is equal to itself. So we know that only angle, the value of whose tangent is equal to itself, is about 4.5 radian. So once 4.5 radian will be there, means that is equals to 4.5. So this value should be equals to 4.5. So tan 4.5 is this one. So now L root P by EI equals to what? 4.5. So just square both sides. Squaring after what you will get? L square into P by EI equals to 4.5 square. So that will be approximate 20.25. That if you will put in the calculator, you will get this value, that is the approximate value. Actually it's coming around 19.86 something, but why we are using this 22.5? So just see that I will tell you here. So from P will be equals to what? 20.25 EI by L square. Now just see, we found earlier 3 equation, but that was in terms of pi, right? 2 pi square, 4 pi square, or simply pi square. So just to convert, roughly we have taken instead of 9.85 or something, that value will come that 20.25, so that this we can write in terms of pi. So now that value of 20.25 is equals to 2 pi square. Okay, so now for 20.25 we can replace 2 pi square and then EI by L square. So this will be the final one. So P equals to 2 pi square EI by L square. Clear? So this is the final P. Okay, so here this you have to remember. So in this derivation only, that value of that radian when it becomes tangent to itself is 4.5 radian, that you have to remember. So just equate this value to the 4.5. Okay, clear? Let's see. Once again I am recalling. Here one end is fixed, another one is hinged. So at fixed end, fixed moment will be there, that is MA. At this, because of this one, just to balance this fixed moment, another horizontal reaction will be there, that is what? That is H. So now what we have to do? We have to find what? The moment. Then only we can put it into the equation. So because of this load P, that this is concave, so minus Py, right? And then this moment MA will be nullified by or equals to H into perpendicular distance up to what? This distance, because up to this is X. So this will be L minus X. So H into L minus X. So total moment will be what? H into L minus X minus Py. So this is the total moment. Next, what we are doing? Just take Py that side, divide EI to each term. After taking that and dividing by Py, d2y by dx square plus Py EI into y equals to H into L minus X by EI. Now another thing is what? That P by EI we can remove. So P is not here. So means we have to introduce the P. So just multiply and divide by P. So after that what we will get? P by EI removed. So what is left? H into L minus X by P. So that term will get added to the general solution. So just say this is the general solution. Here y equals to A cos X root P by EI plus B sin X root P by EI plus this constant term, that this term will get added, that is H into L minus X by P. Okay, now again after putting the boundary condition, what is that? At x equals to 0, y equals to 0, simplified, you will get A equals to minus HL by P. Next step is what? Differentiate. So after differentiating, you will get this one. Again, put the boundary condition, x equals to 0, dy by dx equals to 0. Therefore, what we will get? 0 equals to B into this one. So from here, what we will get? B equals to H by P into root EI by P. So now we have A and B value. Substitute in equation 1, that is in this general solution. So after substituting, next what? Apply the third boundary condition. What was the third boundary condition? At x equals to L, y equals to 0. So just substitute that value. So after putting y equals to 0 and replace x to L. So this will be the final equation 0 equals to minus HL by P cos, so X is replaced by L, so L root P by EI plus HP root EI by P sin L root P by EI. Okay, so now just take this minus to the other side, so this will be the equation. Now take this constant term to this side and cos to this side, so sin L root P by EI divided by cos L root by Pi, that becomes tan L root by Pi, and here what is left? This H will get cancelled, P will get cancelled, so L by root EI by P, that gives L root P by EI. Okay, so now here only the things you have to remember: for becoming tangent to itself, that value of tan will be 4.5 radian, right? So this 4.5 radian you have to use. So 4.5 for this one is equals to L root P by E square. Now next, square both sides, so L square P by EI equals to 4.5 square, which is almost 20.25. Already I told why we are taking 20.25, just so that we can write in terms of pi. So after this, P equals to this one, 2 pi square value is coming around 20.25, so that P equals to 2 pi square EI by L square is the final value for P. Okay, next, now here just see why that time I told you and I wrote you L by 2 in the terms of that one. So just see here, Euler's formula and equivalent length of a column. So the same L will get replaced by L equivalent. So now this one Euler formula is applicable for both with LE values. Okay, where L is the equivalent or effective length of the column. So first condition, just see here, both in fixed, what was the formula? This was pi square EI by L square. So just see here, you put here LE equals to L, right? So you will get this one, that only we got. Next, second, for this one in fixed and the other free, L equals to 2L, so 2L whole square, that is by 4L square, that we got. Next, already I showed you why L by 2, so now just see L by 2 whole square, that will give 4 pi square EI by L square. And fifth, just now, so L equals to L by root 2. After, same thing, this we can write as root 2 into root 2, that root 2 will be in denominator, so L by root 2 whole square. So finally you will get this one. So this is the equivalent length, means by one formula. Okay, if you know the equivalent length, then you can find these all the four formulas. Just substitute the equivalent length, means you have to remember for both in hinged, LE is equals to L, for one in fixed, other free, LE equals to 2L, both in fixed, L equals to L by 2, one in fixed, and other hinged, L equals to L by root 2. So once you remember this one, directly you can put P Euler's and you can get all the end conditions values. Okay, now come to Surrenderness ratio. Okay, so we have already discussed the Euler formula for crippling load. This one, just we had seen the Euler's formula, P equals to pi square EI by LE square, where LE is effective length. So we know that the buckling of a column under the crippling load will take place about the axis of least resistance. So where the least resistance will be there the buckling will be there. That's why in the free case we can see what was there. Here it was fixed, so more resistance, means here buckling is not there, only at the free end like this. So in all the figure you can see wherever this fixed end is there from that time itself it's not starting. First it's go like this, then like this, or from here fixed, okay, like this. So at fixed end resistance is more, so they are not buckled at the more. Where the least resistance will be there, at that case it buckled more. Now substitute I equals to AK square, that is moment of inertia, AK square, where A is the area and K is the least radius of gyration of the section. So you can see moment of moment. The above equation becomes, so now here putting I equals to AK square, so this becomes pi square E AK square by LE square. Now just can we write this as LE by K whole square, take this K square here, so LE by K square, so pi square EA by LE by K whole square. So this ratio of LE by K, where K is what? Where K is least radius of gyration, or 1 by K is radius of curvature. So ratio, now just see how the cylinder ratio is defined, where LE by K is known as the Surrenderness ratio. The Surrenderness ratio is defined as the ratio of equivalent or unsupported length, equivalent length divided by what? Least radius of gyration of the section, right? So slenderness ratio is LE by K, that is equivalent length to minimum least radius of gyration. Okay, because both are length only, so there is no unit, so slenderness ratio does not have any units. Note, it may be noted that the formula for crippling load in the previous article have been derived on the assumptions that slenderness ratio LE by K is so large. So already we had seen some assumptions, means their length should be very long, that then only this Euler's formula is applied. For short column, Euler formula is not applied. Okay, so that's why LE by K should be very large. Thus the failure of the column occurs only due to bending. So if LE by K is very large, then failure will occur only due to bending. If that is small, then direct stress also will be the reason for failure. So the effect of direct stress, that is P by A, is being negligible. But in short column, P by A is not negligible. P by A will be effective, and because of that, the bending will be there. So this is applicable only for the long column. Okay. So now limitations of Euler's formula. Let's see. We have discussed the Euler formula for the crippling load, that is P equals to Euler's pi square EA by LE by K whole square. So now same thing, just Euler's crippling stress. So what is that? P by A. Stress is P by A. So Euler's crippling, this is Euler's crippling load. So just divide here by A. So after dividing by A, what happens? This A will get cancelled. You will get what? P by sigma E, that is Euler's crippling stress, is P by A equals to pi square E by LE by K whole square. Okay, so this will be the Euler's crippling stress. Now here, if the slenderness ratio is less than 80, the Euler's formula for a mild steel column is not valid. So if it's less than 80, then Euler's formula we cannot use for mild stress column. Okay, sometimes the column whose slenderness ratio is more than 80 are known as long column. So if that more than 80 is there, that LE by K value, then we can say that as long column, and if it's less than 80, then we can say it's a short column. So just here, the column ratio is more than 80 are known as long column, and those whose slenderness ratio is less than 80 are known as short column. So by slenderness ratio, we can say that the column is long or short. If column is short, then we cannot apply the Euler's formula, that is for only long column. It is thus obvious that Euler formula hold good for only what? Long column. So this again, oh, wait. So just see once again, this one, I think I explained this again, right? So this equivalent length for the Euler's load is required. So the same of all the formula can be find by one particular formula if you know the what? Equivalent length or effective length. So for all the conditions, this is the effective length. Just put here in effective length in Euler formula, you will get the crippling load or value of P. Okay, so these two are what? The means from this formula only you can find all the formulas. Next, that's why already this is Euler's formula. Now here what we are doing, we are just changing I to, that is moment of inertia is a k square, where k is what? Least radius of gyration. So after putting this becomes P E equals to pi square E into a k square by LE square, and hence this will be pi square EA. Now just take this k square by here. Okay, you can say just divide and multiply k square, right? Or just simply, if LE by k square is there, so this k will come here. So instead of this, we are writing here. So that is also k square and LE square. So we can write simultaneously as LE by k square. And this LE by k is the only slenderness ratio, means the ratio of effective length to the least radius of gyration. Okay, now if LE by k is very large, then only we can apply this Euler's formula. If LE by k is very large, that means small, then we cannot apply the Euler's formula. Why? Because in case of LE by k is very large, then only the bending will be occur due to the crippling. But if Le by K is small, then direct stress cannot be neglected. Okay, so that's why already in assumptions we are saying only the crippling, the failure occurs because of the crippling. There is no direct stress. We are assuming direct stress as negligible. So hence we can say that Euler's formula is applicable only for the long column. Okay, next, this one formula is there already. So this is radius of gyration. So now this value Le by K value, if it's greater than 80, then we can say it's a long column. But in case of the mild steel, it's a less than 80, hence Euler formula is not valid. So means Euler formula we cannot apply it for a mild steel. Okay, so if more than 80 is there, then we can say it's a long column. That's Surrenderness ratio. That is ratio of Le by K is more than 80, then we can say it's a long column. And if Le by K ratio is less than 80, then we can say short column. If Le by K is less than 80, then we cannot apply Euler's formula. Euler's formula is only Le by K greater than 80. Okay. So this is again reference. The book name is Strength of Material, written by R.S. Khurmi. So you can refer, or you can just, whatever your doubt is there, you can just comment here, or you can contact me related to your doubts. Okay. So one more video is only left in this one. Okay. So almost second module got over. So after one more video, the second module will get over. Okay. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.